Hi, everyone. Welcome. I'd like to thank Jeff Gilbert for presenting today. I'm going to give a quick overview of Jeff's background, then he's going to present, and then Jeff and I will walk through any questions that folks have towards the end of the discussion. Jeff currently serves as Director of Operations and Maintenance for Vigilant Energy Management. Vigilant oversees more than 30 megawatts, more than $150 million of PV assets for a wide variety of clients, including utilities, government agencies, and solar contractors. Jeff has more than 19 years of experience in the renewable energy industry. In 2000, Jeff co-founded Chesapeake Solar, a leading mid-Atlantic solar energy company. 8 years later, his company was listed on Inc. magazine's 500 fastest growing small companies. Later that year, Chesapeake Solar was acquired by Grow Solar, one of the nation's leading solar energy companies. Before Chesapeake, Jeff worked for 3 years as an energy analyst under contracts with the U.S. Department of Energy and the National Renewable Energy Laboratories. Jeff served as chair of the Potomac Region Solar Energy Association from 1998 to 2002. He also has been certified by the National Association of Board Certified Energy Practitioners, NABCEP, for both solar thermal and PV systems. Jeff graduated from the University of Maryland at College Park and with a Bachelor's of Science degree in Mechanical Engineering and a specialty in energy technologies. Again, welcome, Jeff, and I'll turn it over to you now.
Thank you, John, and welcome everybody. This is going to be an exciting talk, and I look forward to interacting with you at the end as well. So, PV Systems, Operations and Maintenance Services, protecting your investment. So I'm assuming that our audience includes developers and owners of systems. It could be other O&M companies who are interested in learning tricks of the trade and things like that. I'm going to be speaking mostly about commercial photovoltaic systems. I can certainly answer questions about residential, but all the slides and material that I'll be presenting really gears towards larger commercial systems. A little bit about our company, just real quick. We manage and oversee over 30 megawatts of PV assets, and we're led by a NABCEP certified engineer. We have technicians that include NABCEP certified folks and master electricians and regular electricians. We definitely have a highly qualified team over here. And we use state-of-the-art equipment and reporting capabilities, which is very important. One thing I want to mention, just to go back to the previous bullet regarding our electricians and electricians doing this work in general. Working on photovoltaic systems can be dangerous, especially the larger megawatt-sized systems. Certainly smaller ones can hurt somebody as well, but the larger ones really have a lot of power going through them. And arc flash is one of those things that can really mess up your whole day, and it can also take lives. So if you have people that want to work on these systems who are not electricians, that's scary. They should certainly have arc flash protection training, because these, getting inside these inverters is really quite a dangerous thing potentially. Certainly working on roofs and getting cut, bumped, and scraped and burned by various things are also dangers, but arc flash is definitely the scariest one. All right, so what is the purpose for operations and maintenance? First, it's to maximize the return on investment for those who are plunking down large amounts of money for these systems. And this makes sense. Obviously, homeowners might part with their money for altruistic reasons, but for the most part, larger entities investing in solar are doing it because they want a return on investment. So these systems have to operate for the 30 years that they're planned on, otherwise they're not going to get the full investment return, or at least the period of time that the investors are in it for. They may change hands after a certain number of years, and the initial investor is out after, let's say, 7 years, and then they pass it along. But whoever the owner of the system is, they're going to want to get their return. So it's very important to have a program in place. The second purpose for operations and maintenance is to maximize the total PV production. Now you might be thinking, well, what's the difference? It all comes back to money, doesn't it? Well, yes, but there are entities and people who are also interested in claiming the most offset of greenhouse gases, or offsetting a certain percentage of their electricity uses for their facility. There's a lot of marketing and press and branding around the non-money attributes of renewable energy. So not only, and even just bragging about how your system has been online for 20 years, without any major incident or something like that. So there's a lot of things that are beyond just the cash part of the transaction that are also important. So that's about the purpose. Now, why is O&M so important? Yeah, it's because of money, but because stuff can happen, and stuff does happen. And when stuff happens, power output goes down. That's really the short of it. So what are these things that can happen? Why is it so important? Well, first off, oops, I'm advancing twice at a time here. Because inverter filters can get dirty. I'm going to go through like 5 or 6 slides of examples of what goes wrong pretty typically out in the field that gives justification for having a strong O&M program. And one of the most common things is just to have inverter filters get clogged up and dirty. This is very true for the desert Southwest in California, where there's a lot of dust, but these pictures were taken here in the east, and so we even have problems with dust and clogged filters here in the east. And of course, when the filters get clogged, that means that the cooling fans get overloaded, and they could prematurely fail, which would cause the inverter to fail. And then you're non-functioning and losing a lot of money just because some dirt found its way to your filters and they weren't cleaned out or replaced. Also because debris and weeds can cause acute shading. Some of these sites are our sites, some are sites that we just found nice pictures of, but the occurrence of objects, whether it's a stick or a leaf or a kite or just a wad of plastic somehow that got blown in to that third picture and wedged between modules, or weeds, these things will cause shading, and that shading, if it hasn't been corrected, can cause overheating of cells and premature aging of the panel. And certainly, immediately, it's going to cause a loss in production. So we want to get to these things as quickly as possible. We're in the process of installing video cameras on most of our sites so that we'll be able to keep track of these things as they happen, in addition to actually doing a truck roll and going out there. We also find that combiner boxes have this bad habit of getting wet inside. And now these are NEMA 4 boxes that are watertight. So you might be thinking, all right, how is water getting in a NEMA 4 box? It shouldn't be in there. It's true, water should not get in NEMA 4 boxes. So how does it get in there? Well, it gets in there very commonly from condensation. These boxes are connected with conduit to some other part of the system. And if you're in moist and humid conditions, as we certainly have here on the eastern half of the United States, you can get moisture introduced through the conduit, and it migrates its way to a combiner box. And if that combiner box is cold, as compared to the ambient air, then you're going to get condensation inside. And it's amazing how much water can build up. You can see in these 2 pictures, it's quite a bit of water that can build up in these combiner boxes just from condensation. And this first picture to the left, you can see all the corrosion and slop in there. This wasn't one of the systems that we installed, but we inherited the site and we're maintaining it. And we opened one of these boxes and found actually more water than what's shown here. And the high water caused a ground fault and the system shut down. So that's what triggered us to go out there and do the service call. So this shouldn't happen. These conduit openings should be sealed. And don't use duct seal. That is not rated for outdoor. You should use something like Hayco cord grips, or some kind of a cord grip that's made for these systems, or even expanding foam. Not the Home Depot kind out of a can, but expanding foam that's really made for the purpose. it'll work. The Home Depot stuff will work, but it's not made for the purpose. And why O&M? Also because we get electrical component failures. This first picture to the left had some, had the resistors on this board burned out, so that caused the failure. The second picture is of fuse holders, and if you look there close, you can see that one of the fuse holders started to melt and burn, and that was just because the set screw wasn't tightened down on the tooth of that bus bar. It was a loose connection. It actually came from the factory that way, and we didn't notice this until after several months of it being in operation, and we saw this with our thermographic imaging camera. And the third picture is just of a component processing unit in an inverter that burned out, and it didn't catch on fire or anything, but you can see the scorch marks there at the bottom. So there's certainly a lot of electrical failures that can happen. Next on the list is module breakage. Now modules, I have to admit, are very robust. They're very strong, and breaking is not that common. But when somebody throws a rock, you'll get panels broken. The first picture is from a breakage. There was like a baseball-sized rock close by, so we're pretty sure that that was the culprit. Second picture, same thing. We didn't find the rock in this case, but we're pretty sure because of the impact mark. The third picture, where you see all these arrows, those are not because of rocks. Those are because of seagulls dropping clams. If you can believe it, this site is pretty close to the bay in Atlantic City, New Jersey, and these seagulls, actually if you look really close, you can see a bunch of seagulls perched on these panels in the distance. And these seagulls like to go and take clams and drop them from 25 or 30 feet to break them open. And you can see broken clam shells there in the forefront. And of course, dropping clams from a height will do a mess to PV panels. We are currently working on a mitigation program for seagulls. All right, next we have quality assurance and quality control problems that get overlooked. And sometimes these happen in the factory, sometimes these happen out in the field during the installation. The first picture here to the left is showing a combiner box, very similar to the photo that I showed where the fuse holder was scorched because of a bad connection. This is what that would look like under an infrared camera. This is not the exact same system, but a similar occurrence of a set screw not being tight enough. The picture in the middle there that looks like panels with freckles, that we're still investigating this, but it could be a quality problem from the manufacturer. We have an expert at DuPont who is going to be looking into this more closely to determine what's actually causing these hot spots from cells. And this is just one view, but quite a lot of the panels in the total array had these hot spots. The picture to the upper right is what it looks like thermographically when a bypass diode dies. There's a portion of the panel that actually becomes a load and consumes electricity. So you don't want to have bad bypass diodes and not know about it. You won't be able to see them without a thermographic camera. That's why it's very important to have somebody who's trained to use the proper equipment to see these things. And then the last picture is of a junction box on the back of a panel where there was a loose connection and a failure, and you can actually see this hot point in the junction box. Now what I'm going to do now is go through an example of a cost analysis of what the consequence is of having a megawatt scale PV system go offline. How much does that really cost? Obviously, it depends on what site that you're at and the conditions and what incentives that you're trying to take advantage of. But this would be an example of a site in Maryland. Let's say it's a 1 megawatt site that would, let's say it goes down because of some burned out resistors, and it goes down for 1 week. And I did the calculation for the electricity that a system this size would generate in 1 week, and that comes out to 25,900 kilowatt hours. And I just did a quick PV watts to come up with this number. Normally we would use a much more sophisticated analysis software like PVSys to do our modeling, but I just grabbed the numbers from PV watts for this example. And I'm assuming a cost of electricity for commercial electricity at 10 cents a kilowatt hour, which is not too uncommon in the Mid-Atlantic. I'm not sure how it ranges these days in the rest of the country, but 10 cents is a pretty good number. So the value of, oh, and also we have the value of Maryland SRECs, Solar Renewable Energy Credits, because we have a renewable portfolio standard that's not too bad. We do have the value of some SRECs. And currently they're at about $138 per megawatt hour, which is what an SREC is. So when we crunch the numbers, we come out to $25,900 kilowatt hours times 10 cents is $2,590 per week. That's the offset, that would be the lost value of electricity that should have been offset. And then the cost of the SRECs not grabbed is $3,574. So you put those two together and you lose out on $6,164 just because the system went down for a week. Now if you have an O&M program, your provider would most likely be out there within the first day or two and have the system up and running. At worst, they may have to order a part, overnight it, and it may take 3 or so days, but certainly less than a week. And in some cases, outages like this that are not attended to very quickly could be out for 2 or 3 or 4 weeks, and that would be very costly. Oh, and in this example, I'm not even taking into account the value of offset demand charges. In many commercial sites, not only are people taking advantage of the offset kilowatt hour energy, but also the offset kilowatts demand charge that may come along on their utility bill. Okay, so what are some of the tools of the trade that we folks use out there to make sure that these systems are operating at their peak? The first one that I want to talk about is in the upper left, and this is an example of an IV curve tracer, and I'll go into a little bit more detail on the next slide. But this is a device that really does some fantastic analytics. Solmetric is one of the manufacturers of this device. Also Trica makes one, and I'll show pictures of both of them on the next slide. Right below that is an infrared camera, which is so necessary because there's a lot that goes on that our eyeballs just cannot see. So we need devices to enhance our infrared capabilities. The next picture over to the right is it's a handheld device called an installation resistance tester, or a MEGR. And the design of this is to check for any scrapes or breaks in the plastic insulation in conductors. So if you're pulling wires through a conduit and you scrape them while you're trying to get them into the conduit and you don't notice it, and that insulation has been compromised, then you have a chance for an arc fault or some kind of an arcing. And so this device checks for that. It's very important during the commissioning process, but is also useful during annual evaluations. Then just to the right of that is a standard multimeter, almost standard. It is one that also has DC current measurement, which is very important since we have huge arrays of DC modules that need to be checked for their current output. A regular AC clamp-on amp meter is not going to work for DC voltage, so you got to have a DC clamp meter. Just above is a digital camera, a very obvious tool. Everybody should have one on site. I think we take for granted the power and ability of a digital camera. I can't overemphasize the value of getting the right pictures and a lot of pictures so that, a year or 2 or 5 later, when you're referring to a site and trying to communicate with someone else, maybe the client, you have evidence of all these things that you found and such. That's obvious. In the lower right corner, I have a laptop. Everybody obviously needs a laptop, certainly out in the field, but this isn't just any old laptop. This is a rugged laptop that can withstand being rained on and dirt and vibration and being dropped and things like that. If you take a regular laptop out in the field, it will not last very long. We know this from experience. So get an extra rugged one. Yeah, they cost about $6,000 or so, but they're very worth it if you're doing O&M full-time. Right above that is a typical smartphone, which, again, very valuable. You got to communicate with people. Oftentimes, the manufacturer right out in the field, you got to be in touch with for diagnostics and all the apps that are now available for using these phones out in the field to help us. They're very useful. Next thing I want to do is just spend a couple words talking about IV curve tracing. IV stands for current voltage. The I is actually for current intensity. So what we're doing with these devices is getting a graphical representation of the performance of each of the strings of modules in an array. So we may have, let's say, 14 or 20 or so modules in a series string, and that string is tested. What we'll do is look at the current and the voltage, varying resistance from 0 to infinity, and we get this curve traced out by these machines in just a moment. And what we can tell from these are things like, is there any shading or soiling affecting that array? In some cases, you do a test and you don't even notice that there is bird fouling on the array or a weed climbing up between panels. And you'll see a little wiggle on the curve as shown in these pictures. These two curves you can see are not nice and smooth, but have little stair-step chunks taken out of them. And those anomalies are telling us that there's something wrong, something like shading or soiling or cell damage or even a bypass diode failure, among some other things. So these devices are very useful out in the field, and we really cannot do diagnostics without tools like these. The next one, as I've already mentioned, is the thermal imaging camera. Very important because our eyes just don't see heat the way these devices do. And you can see in that larger picture to the left that we have one of our technicians in an inverter, and the inverter is alive and operating. And that's really the only way that we're going to get good thermographic images is when we have current flowing through these parts. And then we can see if there's any hot spots or anything looking like it's prematurely failing or colder than it should be. You know, if there's a power processing unit that's kind of cold, we know that it's not doing its job. All right, now I want to say a few things about some statistics about failures and costs associated with monitoring systems and doing maintenance. And SunPower Corporation was good enough to share data with us through Green Tech Media, and they put together a nice report. This data shows that inverters are responsible for about 50% of the cost of O&M over the lifetime. So if you didn't know, inverters are the culprits. They're very expensive pieces of machinery, and they're really under a lot of environmental strain. I mean, they're out there in the hot sun or in a box that's in the hot sun or somewhere trying to survive, and they have a lot of power going through them, and there's just all kinds of ways that they can fail. Even if the manufacturer is a really good manufacturer, you can have problems over the lifetime. You should expect it. Next, we have site work and miscellaneous. This is really just, cutting the grass, washing the modules, fixing the fence, upgrading the road, all these kinds of things that happen around the site. Communications is third in line. Then we have tracking system-related maintenance and wiring and modules on the way down. But the main thing to notice here is that the inverters are really the one of the most expensive parts of the system, not only up front, but to maintain. And in this next slide, what I'm showing, courtesy of EPRI, Electric Power Research Institute, in their 2010 study, where they looked at O&M costs, and they've kind of, this is just an excerpt from one of their tables, and you can see here that scheduled maintenance and cleaning really is much of what gets done that's scheduled is about $20 per kilowatt, and that's on the high end, I would say. We're seeing numbers that are for, let's say, a 5 megawatt system, we might be closer to $7 per kilowatt here in the East. And you may be asking yourself, why would we be so much lower than the results of this report? And I think largely it's because a lot of what gets monitored and ends up in these reports is out in California and the desert Southwest, where there is a lot of dust and not as much rain. So modules need to be cleaned off, and that costs money. Here in the East, where we do a lot of our business, most of our business, we don't have to clean the modules every year. In fact, usually around 3 years is the break point where it's time to get out there and actually clean them, because we get a fair amount of rain. So that helps us out. Let's see, the next one there is unscheduled maintenance, about $2 per kilowatt. Then inverter replacement. This has you got to expect this over the life of a system. So that's what we're looking at here, is a total life cycle cost for O&M over, let's say, a 30-year period. And certainly you should expect to replace the inverter over that period. The subtotal for O&M then would be $32 in this case, and then things like insurance, property tax, and owner's costs would add an additional $15 per kilowatt, coming out to a total of $47 per kilowatt. Again, we're just right in that first column. Our experience here in the east is that we're a bit lower than that. It might be closer to $35 per kilowatt, but it varies. It certainly varies by site. The next column over is referring to cadmium telluride as a thin film technology, slightly more expensive for O&M costs. And then the third column there is for single axis tracking of crystalline silicon. And again, because of the moving parts in a tracking system, the O&M is going to be higher. The production, most likely, is going to be much higher as well. So you're not seeing the metric that shows the specific cost, but only the absolute cost for this. In this next slide, courtesy of SunEdison, and they've done a great job with their company of having their own monitoring systems, so they can gather this data very nicely, and we appreciate them sharing this data with the industry through Green Tech Media as well. In this first column, you can see AC subsystems. That's basically everything on the AC side of the inverter. Very expensive equipment because it's high voltage. You know, we're talking about big transformers and switchgear. The occurrence of failure is relatively low, but they're going to be expensive because they're just expensive pieces of equipment. Next in line are inverters. As we already know, they account for most of the failures and problems, and also a pretty high portion of the cost. And then DC subsystems are relatively lower, and then on down through there. Now, let's see, 1, 2, 3, 4. The fifth over is communications. Our experience is that communications is a much higher incidence of alerts or failures. And that may be just because the alert levels that we're choosing to program may be more sensitive than that which SunEdison uses. Also, they have their own proprietary in-house monitoring package, so they may have been able to refine their product much better to keep their communications failures down. So kudos to them for doing that. But for the rest of us that are working with these third-party monitoring companies, you know, our experience is that we're seeing a higher incidence of just communication failures, sometimes not the fault of the monitoring company. Sometimes it's the site host that is, you know, messed up the internet connection or turned off something without realizing it. But our experience is that communications is a higher number. Now, just a few words about cleaning of modules. As I mentioned before, here in the East, we don't have as much of a problem with soiling because we get a fair amount of rain. But this was a study that was put together and was featured in a Solar Pro magazine article, April and May of 2013. And I thought it was a great article because prior to this article coming out, I really didn't have a good sense of what percentage of production gets lost to soiling. And based on a number of locations in California, they came up with, it looks like about 5% loss due to soiling. And you can see there's that one spike that shot way up to close to 15% in 2002, and that was just because of a long summer without any rain there. So the blue line represents not washing at all. The red line and its points represent the modules being washed once per year in June. And so you can see the value of washing the modules is it's about 1%, you know, so maybe 5% loss due to soiling, 4% is what you would get if you only wash the modules once per year in California. Again, it's this California data. But it's nice to know, that washing the modules is worth 1%. And then you could do some quick calculations to determine how much 1% is in value. How much are you gaining in production by washing your modules once a year, and you can cross-reference that to the cost of having somebody go out there and wash the modules, and you can see what the return on investment is for washing. So I thought that was very useful. Lastly, I think this is the last slide, is should you do O&M in-house or should you outsource it if you're an asset owner or manager? And it really depends. There's no single answer to it. There certainly are portfolio managers and owners that have a very robust technical team. Like a good example is some of the utility companies here in the East that have a lot of PV assets. They already have O&M teams. They're already used to doing maintenance on their power plants, and they can just weave this right into their program. But for other companies that, let's say, are EPCs that develop and install these systems and have a limited in-house capability for maintaining them, this is for you, really, I think. So the intent of having in-house O&M is to save money, obviously, and also to have some control over the O&M practices. You'll have a sense of what's going on. You feel like you have more control. This may be a bit of illusion, but at least you have a sense or a feeling of more control. But I should caution those who think that they're always and necessarily saving money and having more control, because troubleshooting modules, inverters, and the monitoring systems takes years of experience to do well. And so if you're just trying to come up the learning curve quick, or thinking that your technicians that are really good at fixing air conditioner systems and repairing and welding things and that type of services are able to quickly come up the learning curve for photovoltaics, you might be a bit disappointed. Also, O&M requires expensive and sophisticated analysis equipment, and it's not just the equipment, but also the experience necessary to use it and to know what to do with all the data that you gather and how to interpret that data. So that's another part of it. And finally, also that when a company specializes in just O&M, they get really good at it and very efficient at it. So they tend to be more cost-effective. So over on the right is a table with the pros and cons of doing in-house or outsourcing O&M. And I got most of this information from EPRI, their 2010 report, but I enhanced it and changed it just slightly. So just looking down on the pros side of having in-house O&M, better visibility on your personnel and the equipment, better quality control and oversight, hopefully. That may be a bit of an illusion, but leveraging existing assets, both personnel and physical assets. You might already have a bunch of trucks and equipment, so you're just using that to continue on a new program. Workforce training. You may already have a good workforce training program in-house, and so this dovetails very nicely with that. Institutionalizing of the PV O&M process. If you have, let's say you're a large utility company and you have facilities, all over your state, and you decide to have your own in-house O&M program, you could have the protocols and procedures be institutionalized within your company, and that way you have, more consistency. I guess that's the advantage there. The cons of having in-house O&M is going to be higher upfront costs, what it takes to ramp up. And you're also going to be adding and needing flexibility that you won't have to get this extra ability quickly. You're going to pay a lot for it, and it's going to take a while. The next thing is a substantial learning curve, as I mentioned before. It really takes something to get good at this. Over on the right-hand column for outsourcing O&M, the pros are, and these are all from the perspective of the owner. So what is the pros for the owner? The advantage to the owner is that it costs less upfront to outsource. You're going to have greater flexibility, lower upfront risk because you're not having to buy a lot of assets or hire a lot of people, less drain on utility labor force. O&M company could train utility to take over the O&M. And this is actually kind of a hybrid arrangement that some utility companies and large asset owners are doing. And that is to, let's say they acquire or install, multi-megawatts. They would have an O&M company come in and do O&M for, let's say, the first 2 or 3 years, but in that process, train their personnel, and after a while, phase it from being outsourced to being in-house. So that's a program idea that could be considered as well. The cons for having outsourced O&M, and again, this is from the perspective of the owner, is less control, or perception of less control, less understanding of the O&M process because they're not involved directly with it, consequences of choosing a cheaper O&M plan. What this means is, in some cases, the owner is really trying to maximize their income from solar, and the idea of spending money on operations and maintenance just makes them cringe. So they say, well, now give me the cheapest plan. I don't want to spend more than I have to. You don't need to give me those fancy reports or go out and do all this curve tracing stuff. Just give me the simple O&M plan. And they could end up spending much more money with a simplified plan than if they had a more comprehensive plan that caught some of the problems before they became catastrophic. So that's really what that means. And then the last one was dependence on an outsourcing contractor. And of course, if you get a bad contractor, then you have to deal with the hassles of that relationship. But that's the case with any commercial business-to-business arrangement anyways. All right, so that's the end of the formal part of the presentation. And now we can take some questions and answers.
Great. Thanks, Jeff. We have a few questions. Jeff, one of the questions, the first question is, I would have thought that trackers would cause larger costs than O&M, even for two-axis. And I guess maybe they thought they would be significantly more, because on your slide 19, it does look like tracking is more expensive, right?
Yeah, it is. And let me kind of zoom into that one.
I think it was 19, yeah, utility scale PV plant O&M cost estimate.
Right, yeah, you were expecting that it might be more expensive. Well, I can't argue these numbers because I didn't see the source data for them. I expect trackers to certainly have a lot of operations and maintenance with respect to the moving components. You know, these things have to last out there in the dust and grit and the heat and keep doing their things over years.
Yeah.
What I did in this is I truncated. I took out a couple columns. If you go to this 2010 EPRI report, you'll see that there, I think, were 5 different columns, 5 or 6, but I shrunk it down to fit on here. And they had, I believe they had two-axis tracking represented as well, and that was even more expensive. As well, I think they had another thin film type represented.
Okay, next question is a technical question. How does shading accelerate the aging of a PV cell?
Well, it does.
Yeah,
that's a short answer. But what we found is when you look at shading, even as something as acute as a bird poop sitting on the panel temporarily, if you look at it using a thermographic camera, you will see a hot spot. You're going to see a spot where the electrons are being absorbed and consumed by that cell. So you're actually going to get a hot spot right at that cell. Shading does the same thing. Now, you know, a bird poop is a cute little spot, but shading from a tree that's close by where the light, the diffused light, hasn't had a chance to kind of creep around and even it out, you will see hot spots. You can see that under a thermographic image. And if the cells are continuously shaded, let's say on a flat roof where you have an air conditioning system, and the designer of the system, well, let's say that the air conditioner wasn't there during the initial installation but got put there, or some other obstruction got put there later, and the people who put there didn't realize that, you know, the effect of shading. You're going to see modules that get shading every day for some portion of the day, and they're going to get thermal cycling. The cells are going to heat up, and they're going to wear out sooner. I don't have exact data on how soon they're going to fail, but they're not going to last the 25 or 30 years that modules should last, but I just don't know by how much less.
Yeah, it's just the concentrated heat that's dedicated to the cells that
exactly. Now one of the, with modules, as we all know, that they degrade over time. That's why the manufacturers give a 12 and a 25-year warranty. What happens on a I guess microscopic level, certainly on a zoomed-in level, is you get micro cracks and damaging that happens because of thermal cycling. And when you shade cells, they're going to go through more extreme thermal cycling. So you should just expect them not to last as long.
Okay. Okay. Next question. At what kilowatt size do you think it really becomes O&M becomes effectively a requirement? And 100 kilowatts, 250, 1 megawatt.
Great question. Great question. We have a number of systems that are under our care that are as small as 5 kilowatts, and we go all the way up to 5 megawatts. But the smaller ones still require something. We just sold a contract to a township on their police building, and where the mayor has her office, and it's just a 20 kilowatt system. And I proposed to them what we call our bronze package, which really is just monitoring and an alert notification, and then everything, if we actually have to roll the truck, we'll do it on a time and materials basis. And we thought that that was going to be most cost effective for them. And they actually upsold us. They said, no, we want your silver package, which includes some extra reporting and the site evaluation and documentation, because we need the documentation for our board of directors and our people. So that was it was nice that they actually upsold us. But I would say any size merits some level of an operations and maintenance program. Smaller ones, maybe just monitoring and alert notification, and then everything else can be kind of on a time and materials basis. And then the larger you get, or the more that your customer needs documentation, yes, we came out twice a year, and here it says so. Here was the report. On up to the big stuff, the big cost.
Okay. Next question goes to microinverters, and I guess let's throw in optimizers as well. Do they have the same O&M cost issues as string and central inverters, or are there
obviously
fewer,
they're a
or
little
more?
different. All of our assets that have microinverters are residential or very small commercial. So I can't speak to some of the projects where microinverters are being used on 50 and 100 kilowatt systems. Okay. I do know that historically the microinverter manufacturers were going through some growing pains, and their failure rates for earlier product is pretty high, and so far all of those inverters are under warranty, so it's just a matter of doing an RMA, changing it out, and they reimburse a bit for labor. I haven't given enough thought to the comparison between microinverter maintenance and the larger systems, because all of our assets are residential. But certainly we have residential teams that go out, but we don't sign contracts for O&M for residential. We just do that on a time and materials basis.
Okay. Yeah, and I guess microinverters present some cost advantages as far as production output of the system that would certainly need to be taken into consideration as well.
Yeah.
Okay, here's someone, they just wanted to note that better O&M will lead to better industry-wide performance data that will in turn help attract more capital to solar projects. Yeah, I think that's fair to say. What is the difference between thermal imaging and infrared?
There is no difference. They're just different ways to describe the same thing.
Okay. Do you have any any experience with automatic washing systems?
No direct experience. I've seen advertisements for them, and I've seen advertisements come and go, which tells me that maybe those products didn't work so well, or they just couldn't sell them and keep that business model running. No, what we do, we actually farm out our outsource, our cleaning, because our technicians are so highly skilled and expensive that we don't want them to be washing modules.
Okay. Are there any guarantees in place by outsourced O&M companies, meaning in the event of an outage, will they promise to be there within X number of days, for example?
Yes, we've run into that a few times. Where we're working closely with the EPC, and that's what is required by the request for proposals. So we have to, if we want to bid on the project, we have to comply with what they're insisting on. And of course, we cringe. We're like, oh, how could we guarantee something that's like gambling? We don't like gambling. But yes, we do that when it's insisted on. And how do you do it? You just, you use your best judgment. Things like an annual assessment or a semi-annual report, those are things that are very scheduled and you can control those costs. Things like, force majeure or, inverter companies going bankrupt and not having parts available, things like that. Those are the things that scare us as O&M providers. If we lock in on a 20-year contract and somebody wants everything included, they're going to get a very high price. If they want all those guarantees. I don't recommend that unless they really have to annualize their costs, and they kind of need that upfront price.
Okay. Have you worked with contractors that have performance guarantee needs? And if so, are there any special issues there, or it sounds like maybe that's tied to the question we just talked about?
Yeah. So I think everything I just said applies there. That yes, it does happen. I think it's become a bit more common that investors want. They're scared. They're scared of putting out $10 million on a project. It's a lot of money and it's scary. So they want some kind of guarantee. So they try and put some of that onus on us, so we can be scared.
Are there any unique things that you do, or policies, practices that you incorporate into the system to deal with potential animal and pest damage?
To some extent, residentially, I think it's fairly common to do what we call squirrel cages or bird cages, basically putting netting or metal netting around the perimeter to keep critters from getting in, or even leaves and debris from getting under the modules. As far as larger commercial sites, we have or we're installing video cameras so that we can monitor them. But I mean, if a critter comes along and starts chomping, and we're 2 hours drive away, all we could do is watch them chew. And dispatch the truck. So we haven't implemented any procedures other than fences, to keep the larger animals out from back scratching on the arrays and things like that. But things like, I don't know, all these methods that people use for keeping deer out of their gardens, wolf pee and bars of soap and nothing like that.
Okay. What time of day, if there is a best time of day, are infrared scans best conducted?
Right in the middle of the day with bright sunshine. You really want the current in the modules and other equipment to be maximum. Otherwise, you're not going to see it heat up. You would think, well, no, I need to be on a cold day so I can see the heat, but that's not true. With a thermographic camera, you're seeing relative heat. So even if the surface of your panels is 140 degrees Fahrenheit, hot to the touch, looking through a thermographic camera, you're looking at a relative difference. So the panels will still look relatively cold compared to the hot spots.
Okay, we've had a ton of snow relative in the D.C. area, but I know, you go further north and even in Michigan, some historical levels of snow. How's that issue addressed? And, getting up on the roof and on residential, how do you folks deal with that?
Well, we certainly, the recommendation is don't climb up on your roof and sweep off snow, but I will admit that I've done it before, so it does happen. Gosh, a lot of snow is really going to kill production, and there's nothing you can do except for have some kind of a mechanical way to clean it off. If you can do it safely, do it. On a larger scale, what we're noticing is that, in fact, just recently we had a client call us and showed us some pictures of the snow sliding off this was a carport. And fortunately nobody was injured, but the snow slid off and made giant piles, right there in the parking lot. And that could have been somebody walking underneath or a car getting damaged. So now we're looking at different methods for correcting that, either mechanically removing the snow before it slides off or having some kind of little guards that hold it there. Of course, I also just got pictures of carports in New Jersey that tipped over because of the heavy snow load. So I think that was a structural issue, and that shouldn't happen even with 2 feet of snow. But one of the concerns was, gosh, if you put guards on there to stop the snow from sliding off, then it'll stay up there and become a structural problem. But it shouldn't if the system was constructed properly. I don't have a single answer, only a lot of ideas and thoughts and reflections on my experience.
Now, O&M contracts, scheduling, what are you seeing, and what do you think the trend is as far as who enters into that? I mean, are you ever seeing any contractors that are doing the installation, entering into a long-term O&M, or is it largely the system owner that takes ownership of it and then they enter into the O&M contract?
Well, I don't have statistics all across the states, but primarily what we're seeing is that it's the asset owner that we're contracting with most on large projects. On medium-sized projects, let's say 100 kilowatts and less, we are seeing more of the EPCs coming to us. In fact, someone just called me earlier today, and they're in that situation, so we hope to work with them. The EPC may have taken on some liability and responsibility for maintaining the system over 20 years, and maybe they're looking at the economics of in-house O&M versus farming that out, and it may be much more cost-effective for them just to partner with an O&M provider. We're seeing both in our portfolio, but I would say it's the larger majority is that we contract with the owners of the systems.
Okay. Do O&M services include warranty management? Further to that point, if we're talking about an inverter that has proprietary software, how do you address that issue? I guess is that through the warranty program, or is that an issue? You find that's an issue?
I haven't bumped into the proprietary software part. We do have a couple clients that will not give us access to monitoring because of security problems, and so they simply call us when there's a problem. But as far as the warranty maintenance, anytime that, let's say, the inverter goes offline and it's covered under warranty, as soon as we get the alert, we let the client know about it, and we call the manufacturer immediately and say, hey, there's a problem, and maybe we already know what the problem is or not, but the inverter manufacturer sends out a technician and us. We'll go out there to the site as well. But that coordination is a very integral part of the O&M contract.
Okay. Can you give just a very high-level overview of what would be typical types of service packages? Like I think you had said silver, bronze. Can you give us a high-level overview, maybe on the commercial side and
Sure.
time permitting on the residential side, as to what are the differences between the various packages?
Sure. We have our packages, but I've looked at sites of other O&M providers, and there seems to be some agreement, some consistency that there's different levels. The simplest level, it would be usually for smaller projects, 20 or 50 kW, where they can't justify the big gold package because they're only making a small amount of revenue from their system to begin with. So we try and make everything simply monitoring and coordinating any warranty issues. That would be like our simplest package. Our silver package would be including at least an annual site walkthrough with maybe a system site evaluation light For example, maybe only 45 or 50 point inspection versus 120 point inspection or something like that. So it still has eyes on the system. It still gives a chance for corrective measures, but not a full-blown system evaluation. And so that would, and of course there'd be a report to go along with that. So that's the next level up. It's sort of full package light. And then of course the gold, it would be the full package where we do curve tracing, thermal imaging, full report. We even look at their performance and compare that to the weather-adjusted model that they should be producing, a certain amount, and we compare that. We do the analytics, and we send them a complete report on that. So they're really getting everything, and this really is justified for, everything that's above, 300 to 500 kilowatts. I would recommend having a more full package like that. We also have what we call our Platinum package, which is full asset management of metering and billing, so that the owner of the system doesn't have to, let's say it's a third-party PPA arrangement and there's a host site that's getting billed monthly for the electricity. There is there's some administration involved with metering and sending a bill to the customer and collecting that, and there's the whole administration of it and paperwork. So that would be our Platinum level. It would be kind of all of the services of our Gold O&M package plus metering and billing.
Okay, we're a little bit over, but just two more questions. One, very quickly, someone had asked if the utility scale PV plant O&M cost estimates, the EPRI data, if those were on an annual basis. And looking at the slide, it looks like they are.
They are.
Okay.
Yep.
And then if someone is looking to create an in-house program, what are some of the training opportunities for staff? So if you want to build a team, what do they work with manufacturers? Do inverter companies have programs where they provide training for O&M providers, anything like that in existence?
I think there's probably a couple training companies like Solar Energy International out there that have some O&M training programs. But I think right now, actually, I've been looking at creating such a program and making it available nationwide. But that's, it's one of those things that may take a year or so to develop and put out there. In the meantime, training comes really from piecemeal. So yes, the inverter manufacturers will give you training on their product, and obviously being an electrician and getting safety training is very important. So it's, you going to these trainings, just getting NABCEP certified and being familiar with how these systems work is part of the training that it kind of leads to the experience to be a troubleshooter.
And Jeff, really instructive, very helpful, and we really appreciate your time today.
You're welcome. My pleasure.